Today we're covering section 1-2, solving linear equations. So a linear equation, to refresh our memory, is just an equation that can be written in the form ax plus b equals 0. You might be most used to seeing it in slope-intercept form, or y equals mx plus b. But when we get into solving some of these equations today, they might get a little bit more complicated than you're accustomed to seeing. So because of that, we need to think about extraneous solutions, which is just a solution that does not satisfy our original equation. So say we solve an equation, we end up getting two answers for x. We substitute both of those answers back into the original problem, and one or both maybe don't work. So before we get started, I do want to go over the quadratic formula. Now, I know it's something that you covered in Algebra 2, and we are going to formally go over it in a later section, but I just want to refresh our memory because we need to use it in this section. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we'll remember a, b, and c are just the coefficients of a quadratic equation. Okay, so our first example is pretty basic, pretty straightforward. So we have 14x minus 6 is equal to 21x minus 22. So if we are trying to get x by itself, I'm going to subtract 14 from both sides. 14x from both sides. And we're left with negative 6 is equal to 7x minus 22. And then I'm going to add 22 to both sides. And we get that 7x is equal to 16, and then divide both sides by 7. And we have that x is 16 sevenths, which is fine. Please leave it as an improper fraction. Okay, you don't need to write it as a mixed number. All right, moving along to b, we see we have our variables inside parentheses, so refresh your memory of distributive property. So we get negative 2x plus 2 is equal to 15x minus 40. I'm going to add 2x to both sides. I'm going to do two things at once here. Then I'm going to add 40 to both sides. My 2x's go away, my 40's go away, so I'm left with 42 is equal to 17x. Divide both sides by 17, and we get that x is 42 over 17. Now do double check, and I'll bring my calculator up here so we can check. Take 42 divided by 17, math, enter, enter. It doesn't reduce our fraction, so that means it's not able to be simplified. So we're done. All right, now let's take a look at example 2. So for example 2, I'm sure some of you are like, oh, it's fractions. Nobody likes fractions. So because we don't like fractions, let's get rid of our fractions right away. So we could go through and solve this by finding a common denominator, and maybe I'll show you both ways here, or I'll do the your turn. I'll show how to do that a different way. But for this one, let's just eliminate our denominator first. So if I look at 3 and 4 and say, okay, what is the LCD, or the least common denominator? We look at it and say, well, that's 12. So that means I need to multiply every single thing here by 12, like everything. So if I multiply that by 12, and then the 2 by 12. So 12x divided by 3, well, that simplifies to 4x, plus this 12 and that 4 reduce. So 3 times 3x gives me 9x, and then 2 times 12 is 24. And our fractions are all gone. So 9 plus 4 is 13x equals 24. So x is going to equal 24 over 13. Again, cannot be reduced anymore, so we're finished. Okay, now the next problem. This is the your turn. So I'm just going to complete this problem and show you the other way. We could find a common denominator, just like we did when we were adding rational expressions. Okay, so the common denominator of each of these is 30. So that means the 6 I multiplied by 5, so I get a 10x in the numerator. I multiply the 5 by 6, so I get a 6x in the numerator. It's still equal to 2, but I'm going to make that 2 into a fraction. And you'll see why here in a second. When we add fractions, we add the numerators and keep the denominators. So we get 16x over 30 is equal to 2 over 1. So I did it this way, that way you could see to cross multiply. Some people don't really need to cross multiply. If I just left it equal to 2, they would say, okay, I have division of 30, so I'm going to multiply by 30. So either way you think about it, that's what we need to do. So we end up getting 60 equals 16x. So we get the x is 60 over 16, and that does reduce to 15 over 4. So we can divide each of them by 4. And if we would have multiplied every term by 30, we would have ended up getting the same answer. All right, moving on to example 3. This is where it gets slightly tricky, because now our fractions they have expressions in the denominator. So again, we could multiply everything by the LCD to get rid of them, or we can find a common denominator. So since most people in class preferred finding the common denominator rather than the LCD method, we are just going to go through and solve it like that. So my common denominator, I'm going to rewrite this as one fraction to start with. It's just x minus 2 times x plus 2. I'm not worried about the 16 because it's on the other side. We're just going to leave that there for now. So my first numerator here was missing an x plus 2, so I had a 1, so now I have an x plus 2 plus, don't forget we're adding, I have a 3 times, now what were we missing? I had a plus 2, so we were missing an x minus 2. Okay, I'm going to simplify my numerator. So I get x plus 2 plus 3x minus 2, minus 6 I mean. There we go. Don't want to make small mistakes again. And I'm going to simplify this even more before I get to the other side. So 3x plus 1 is 4x minus 4, okay? And that is all over x minus 2 times x plus 2, and that is equal to, now since I have a fraction, I'm going to do 16 over 1. So again, we can think about it as cross multiplying. I know some of you find that beneficial. So I get 4x minus 4 equals 16 times. Now I know that right there is difference of squares, so that is x squared minus 4. So I did two things there. I cross multiplied, but I also simplified x squared minus 2 times x, or sorry, I simplified x minus 2 times x plus 2 into x squared minus 4. Right, so now I have to distribute my 16. Notice my fraction went away since we cross multiplied. Okay, now I have an x squared term and an x term, which means it's quadratic, so we need to get everything to one side and set it equal to 0. So 0 equals 16x squared. I have a minus 4x and a minus 60. Okay, I subtracted the 4x, I added the 4 to the negative 64. All right, so at this point, we could factor out a 4. So let's go ahead and do that, make our lives a little bit easier. So 16 divided by 4. Hang on one second, my thing's ready. All right, 16 divided by 4 is 4, so I get a 4x squared minus x minus, and then 60 divided by 4 is 15. Right, so at this point it is technically the zero product property. So I would set 4 equal to 0, and we say, oh, that doesn't make any sense, doesn't work. So we sort of forget about that 4. But then we have 0 equals my 4x squared minus x minus 15. Now I could try factoring this, but I'm going to tell you right now it's not factorable because we end up getting all these weird decimals. So we are going to use quadratic formula. So my a value is 4, my b value is -1, and my C value is negative 15. So again, if we remember it, negative b plus minus the square root of b squared minus 4ac all over 2a, right? Not too hard. Just substitute in the values that we have. So I have negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 4, times c, which is negative 15, all over 2 times 4. So we have some work to do here. Let's go ahead and bring out our calculator, get some of this multiplication done. So negative times a negative is a positive 1, plus or minus. Whoa, that's a bad minus. All right, so I'm going to go ahead and do all this. So I know 1 squared is 1. So I have 1 minus 4 times negative 15. And I am going to go back here and put this in parentheses. Even though your calculator does know order of operations, so it would multiply all of that first. But we just want to make sure. So we get 241. Guess I don't need this to be too long. There we go. All over 8. So we could leave our answer like that if we wanted to, because it's going to be decimals. We could simplify or see if we can simplify the square root of 241, but I'm going to go ahead and also find this decimal answer, or both decimal answers. So I'm going to do 1 plus the square root of 241, and then divide that by 8. So we get, x is equal to approximately 2.0655. We'll do 4 decimal places. Oh, that is 4. Okay, so we're done there. And then, since I did 1 plus, I need to do 1 minus the square root of 241. 1 minus the square root, there I go, 241, divided by 8. And we get x is approximately, I'm going to fix those, to negative 1.8155. Okay, so there's our decimal values. So I want you to pause the video, take a second, do try this next your turn. I'm going to write the answer, that way you can check your answer when you're done, or we can go over it in class tomorrow. I will write you are going to need quadratic formula. So I'll give you that heads up. So pause it now, then come back and check your answer. All right, moving along to our last example. All right, this one is linear again. So it says a delivery company has determined that its average annual operating cost is C equals 1.9x plus 2100, where x is the number of packages delivered per year. All right, so that's the equation we're looking at. Part A says find the y-intercept of the graph of the linear model algebraically. So y-intercept, well, that is where we let x equal 0. So let's take our equation, c equals 1.9 times 0 plus 2100. 1.9 times 0 is 0, so c is $2,100. So let's think about what that means. If x is the number of packages delivered per year, if we deliver, or if this company delivers no packages all year long, they still have an average annual operating cost of $2,100. Okay. So part B says, how many packages can this company deliver in a year with an operating cost of $12,000? So it says their operating cost. So that's our C value. So that means I'm going to have 12,000 equals 1.9x plus 2,100. All right, so now I'm going to subtract 2,100 from both sides. I get 9,900 equals 1.9x. Divide both sides by 1.9, and we get that x is approximately 5,210.526 packages. Well, we can't deliver partial packages, and I can't round this up because I don't quite have enough money. 1,200 isn't enough to deliver 5,211 packages. So we would have to say they can deliver 5,210 packages with an operating cost of $12,000. All right, so this is the last your turn. Go ahead, pause the video, try this your turn, and then come back and check your answers.